And so this is our Isaac GR00T platform. The simulation is exactly the same as Omniverse. The training system is the same. When you're done with the model, you put it inside this Isaac GR00T platform. And Isaac GR00T platform starts with a brand new computer called Jetson Thor. This is just started in production. It is an incredible processor. Basically, a robotic processor goes to self-driving cars, and it goes into a humanoid robotic system. On top is an operating system we call NVIDIA Isaac. The NVIDIA Isaac operating system is the runtime. It does all of the neural network processing, the sensor processing, pipelines all of it, and deliver actuated results. And then on top of it, pre-trained models that we created with an amazing robotics team that are pre-training these models. And all the tools necessary in creating this, we make available, including the model. And so today we're announcing that Isaac GR00T N1.5 is now open sourced. And it's open to the world to use. It's been downloaded 6,000 times already, and the popularity and the likes and the appreciation from the community is incredible. And so that's creating the model. We also open the way we created the model. The biggest challenge in robotics is, the biggest challenge in AI overall is, what is your data strategy? And your data strategy has to be, that's where a great deal of research and a great deal of technology goes into. In the case of robotics, human demonstration, just like we demonstrate to our children or a coach demonstrates to an athlete, you demonstrate using teleoperations. You demonstrate to the robot how to perform the task, and the robot can generalize from that demonstration, because AI can generalize, and we have technology for generalization. You can generalize from that one demonstration other techniques, okay? And so what if you want to teach this robot a whole bunch of skills? How many different teleoperation people do you need? Well, it turns out to be a lot. And so what we decided to do was use AI to amplify the human demonstration systems. And so this is essentially going from real to real and using an AI to help us expand, amplify the amount of data that was collected during human demonstration to train an AI model. Let's take a look.
The age of generalist robotics has arrived, with breakthroughs in mechatronics, physical AI, and embedded computing. Just in time, as labor shortages limit worldwide industrial growth. A major challenge for robot makers is the lack of large-scale, real, and synthetic data to train models. Human demonstrations aren't scalable, limited by the number of hours in a day. Developers can use NVIDIA Cosmos Physical AI World Foundation models to amplify data. GR00T-Dreams is a blueprint built on Cosmos for large-scale synthetic trajectory data generation, a reel-to-reel data workflow. First, developers fine-tune Cosmos with human demonstrations recorded by teleoperation of a single task in a single environment. Then, they prompt the model with an image and new instructions to generate dreams, or future world states. Cosmos is a generative model, so developers can prompt using new action words without having to capture new teleop data. Once a large number are generated, Cosmos reasons and evaluates the quality of each dream, selecting the best for training. But these dreams are still just pixels. Robots learn from actions. The GR00T-Dreams blueprint generates 3D action trajectories from the 2D dream videos. This is then used to train the robot model. GR00T-Dreams lets robots learn a huge variety of new actions with minimal manual captures. So a small team of human demonstrators can now do the work of thousands. GR00T-Dreams brings developers another step closer to solving the robot data challenge.
Is that great? So in order for robotics to happen, you need AI. But in order to teach the AI, you need AI. And so this is really the great thing about the era of agents where we need a large amount of synthetic data generation, robotics, a large amount of synthetic data generation, and skill learning called fine-tuning, which is a lot of reinforcement learning, and enormous amount of compute. And so this is a whole era where the training of these AI, the development of these AI, as well as the running of the AI needs an enormous amount of compute.